All right, so this is the Chapter 12 and part of Chapter 10 review video tutorial, kind of how to set up the problems and what answers you should be getting. So for question 1, we have a satellite is 17,600 miles above the Earth. Earth's radius is 4,000 miles, so we're going to put 4,000 here and here. The satellite is sitting at 17,600, and they want to know how far on the horizon can you see or how far on the Earth's surface on the horizon can you see from the satellite. So with this problem, we remember a radius meets a tangent at a right angle. So we're looking at a setup using the Pythagorean theorem. So x squared plus 4,000 squared equals, and then we'll add together the 4,000 and the 17,600. You get 21,600 squared. And ultimately, you want to solve this using the Pythagorean theorem. So you square both, subtract, and then square root. And you should get that horizon distance is right around 21,226.4 miles. Question 2. AB is a tangent to circle O, so we know this is making a right angle. We want to find the length of the radius. Well, we have two of the radiuses here. They tell us AC is 8, so that is 8 there. And in this case, AB is 12. So we would set this up as r squared plus 12 squared equals r plus 8 squared. We're going to need to FOIL the right half of the equation, so with that, we kind of simplify as we go. R squared plus 144 equals r squared plus 16r plus 64. Then we just want to simplify. We'll subtract the r squareds, subtract over 64, and we should solve for r and get r to be 5. So your radius is just 5. Question 3, circle O and circle P are congruent. They're telling you that arc RS is congruent to arc UV. And so what else can we know from this? Well, one of the things we'll know is that chord RS is congruent to chord UV. We would also know that the central angles that make them, so angle SOR, should be congruent to angle UPV. Here we've got circle Z. We know that BZ is congruent to FZ. We know that these lines are perpendicular to those chords. If AB is 16, what do we know about CF? Well, if AB is 16, this part here is also 16. But we also know that AC should be congruent to DC. So this would be 16, and this would be 16. So that means CF has a length of 16. Questions 5 and 6. What can you conclude about the image above? Well, in this case, it's to the left. It's not above. But they tell us that AB is a diameter and that AB is perpendicular to CD, so we have right angles here and here. And so in this case, it's telling us because of the diameter being perpendicular to this chord, we know it bisects the chord. So that means CX is congruent to XD. We also know that the arcs behind them, in this case CA, should be congruent to AD in this case. With this information, it asks if the measure, or find the measure of CB if AD is 34. Well, CB is this, and AD is 34 here. Well, we know that if this is 34 from the previous problem, AC is also 34. We're dealing with half the circle here. So to find CB, we're just going to take 180 minus 34, and we get CB to equal 146. Question 7, they've asked us to find the length of x, which is a radii, so we're just going to redraw it, because we're able to redraw the radiuses. So we'll put x here. Instead of 16, we're going to use 8 and 8 here. So we're going to use the Pythagorean theorem to find x. So that means we've got 5 squared plus 8 squared equals x squared. In this case, we should get x to be right around 9.4. We'll do the same thing in question 8. We'll redraw the radii, or the radius here. So we get 13. And instead of solving for x, let's call this y for right now, because we're gonna have to remember that in this case, 2y's is going to equal the entirety of that x value. So we'll get 5 squared plus y squared equals 13 squared. In this case, we're going to get y to equal 12. So that means x equals 24. Question 9, they tell you that the radius of circle O is 25, so we've got 25 here. OC is 8. Find AB to the nearest tenth, but we're just going to find x first, and then we'll just double it. So this is another Pythagorean theorem problem. So you've got 8 squared plus x squared equals 25 squared. So we just solved the Pythagorean theorem. You get x to be right around 23.7, and then we double it. So AB is 47.4. In 10, FG is congruent to RS. And then you have all this other information. So basically, we know that these measurements are done perpendicularly. And they tell you OP is 13. Well, if the chords are congruent, that means that they are also equidistant from the center. So that means if this piece is 13, x is also 13. So your answer here is just x equals 13. In 11, find the measures of the indicated angles in circle O. Well, we can start with B. B is pretty easy. It's a central angle, so it matches the arc it cuts, so 122. A cuts that same arc, but it's an inscribed angle, so it's going to be half of 122. So in this case, A is going to be 61. E is an inscribed angle that cuts at a diameter, so E is going to be 90, so half of 180. C is a central angle that cuts the other portion of this arc that's a part of the semicircle made with 120 there. So if we take, or 122, so if we take 180 minus 122, we're going to find that C in this case is going to equal 58. And then last but not least, angle D cuts that same arc as angle C, but angle D is an inscribed angle, so it's half of it. So D in this case is just 29. Here they're telling us that angle R is 32 degrees, and they want us to find the measure of angle O. Well, angle R is 32, so that means the arc that it's cutting here is double that, so 64. Angle O, however, is a central angle, so it's going to match the arc it cuts, which happens to be the same arc that R cuts. So in this case, angle O is just 64 degrees, so it matches the arc exactly. Question 13 asks us to find the measure of BAC in circle O. So BAC is this inscribed angle here. I didn't do a very good job of highlighting it, but it is the inscribed angle. That's not any better. So we have an inscribed angle here. They tell us that the central angle here at BOC is 53, so this arc has to be the same as that central angle. Well, BAC cuts that arc of 53. So to find the measure of angle BAC, we merely have to cut the arc in half. So BAC should equal 26.5 degrees here. In question 14, you've got AC as a tangent to circle O at A, and they've asked us to find the measure of YAC, so this angle here, if we know that the measure of BY is 44. Well, we know that this half of the circle is a semicircle, so 180 is the total. So if we take 180 minus 44, we get 136. YAC has its vertex on the circle, so the angle is going to be half the arc. So that means the measure of angle YAC is equal to half of 136, which is 68 degrees. Question 15, they tell us that RT is 44 degrees, or arc RT is 46 degrees, sorry. They tell you that arc RS is 86. And they ask you to find the measure of angle U, which is here, as well as angle S. Well, angle S is the easiest one to find. It's an inscribed angle, so it's half of the arc it cuts. So it's going to be half of 46, which makes it 23. Angle U, however, is outside the circle. So the measure of angle U is going to be equal to 1/2 the difference of the two arcs that it cuts. So 86 minus 46, which in this case would be 1/2 of 40. Half of 40 gives us a measure for angle U equal to 20 degrees. In 16, they want you to find the measure of angle X here. They tell you that AB is 38 and CD is 47. Well, angle X lies in the center of the circle, not in the center of the circle, lies within the circle. So we know that in order to find the measure of X, we're going to have to take half of the sum of the two arcs it cuts on opposite sides. So 47 plus 38, that's going to be 85. Half of 85 is going to give us the measure of X to be 42.5 degrees. Question 17. A park maintenance person stands 16 meters from a circular monument. Assume that her line of sight from the tangents of the monument make an angle of 44 degrees. So we've got a 44 degree angle. What is the measure of the arc of the monument that her lines intersect? So they're looking for this measurement, but remember the rest of the circle, this is one of those 360 minus X problems. So we should be able to set this up as the outer angle, 44, equals 1/2 the difference of the two arcs. So we'll simplify this down. We've got 44 equals, and we can distribute this, we get 180 minus X. We'll go ahead and subtract over the 180. We get negative 136 equals negative X. So that means the degree of the arc she can see is 136 degrees. Or the degree of the fountain, or monument, sorry. Here they've asked us to find the length of this tangent, given a secant that intersects the circle. So to set this up, we take the tangent squared equals the sum of the secant, which in this case is 27, times the outer portion of the secant. So we're going to multiply this out, then square root, and we should get that tangent is right around 15.6 units. All right. In 19, we have two chords intersecting in the circle. So to find the value of this X, we're going to take the product of each part of the chord set equal to the product of each part of the other chord. So that'd be 10 times X equals 7 times 22. So 10X equals 154. Divide by 10, you get X equals 15.4. In 20, they want us to write the standard equation of a circle in the graph. Well, our center, we should notice they're counting by twos. So our actual center value is, for X, it's negative 2, 4. So that'd be H and K. And our radius in this case, if they're counting by twos, is just 4. So when we write our equation, it's going to be X plus 2 squared plus Y minus 4 squared equals 16. In 21, they give us H and K, but we need the radius, so we're going to use the distance formula. And so in reality, we're going to end up with negative 3 minus 0 is just negative 3, so we've got negative 3 squared plus negative 4 squared here. So that's 9 plus 16, that's going to be the square root of 25, so your radius is just 5. So then we set up our equation. So X plus 4 squared plus Y plus 3 squared equals 25. 22, it says find the measures of arc ADC and DA. Well, ADC is the majority of the circle here. And we know that if this is 103, we have arc here is 103, 23. We don't know what this piece is, but we do know it's a part of a diameter. So we take away 180, or part of a semicircle, so 180 minus 35 would be 145 here. So to find ADC, we're just going to add up all of those measurements there, and we get ADC to be 275. And then to find DA, we can kind of backtrack here. So we'll get rid of the stuff we don't need. So for DA, you're looking from here to here. Well, DA would be a minor arc, sorry. DA is going to be this piece here, so you would take 27 plus 103. In this case, arc DA is just going to be 130. 23 wants the circumference and the area. So circumference, we would have pi times diameter, which in this case is going to be 48 pi feet. And then area, pi r squared. Well, in this case, your diameter is 48, so your radius is 24. So you've got pi times 24 squared. So your area in this case is going to be 576 pi feet squared. In 24, it asks you to find the area of sector ABC. So area of the sector is going to be 60 over 360 times the area of the triangle, or area of the circle, pi times 15 squared. So in this case, we're going to get 15 squared times 1/6 is going to give us 37.5 pi, in this case, inches squared. And then your arc length, very similar. We're going to have 60 over 360 times circumference, so 2 pi times the radius of 15. In this case, your length should be right around 5 pi inches. And then in 25, they're asking you to find the area of the segment. So we're going to take the area of the sector minus the area of the triangle. So sector area, you're doing 90 over 360 times area of the circle. So pi times 4 squared. This time I'm going to take the area of the sector and put it in decimal form. So it's right around 12.6. Then we find the area of the triangle. Well, that's 1/2 base, so the base is 4, the height is 4. They meet at a right angle, that's how we know. And the area of the triangle in this case is just 8. So to find the area of your segment, you just subtract the two areas, and you get that your area of just this shaded region here should be 4.6 meters squared.